Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. I hope all is well with everyone. Today we're going to be talking about factoring special products, guys, and then just general factoring strategies. Basically, I'm wrapping up factoring strategies today, okay? So we're going to go over the last section, and then we'll wrap everything up to make sure everyone understands what to do. Now, there's good news and bad news here. These are really easy, okay? That's the good news. The bad news is you have to learn a format. You have to learn a formula in order to really be proficient with this skill. So when I have a perfect square, I'm going to have a trinomial in one of two ways and only one of two ways when I have a perfect square trinomial. And it's going to be in the form of a squared, so that means that my first term is being squared, whatever that is. Then my second term is 2 times a times b. That means it's 2 times the square root of the first term plus 2 times the square root of the second term. Okay, so it's 2 times the square root of the first times the square root of the second plus b squared. That means that my last term is also a perfect square. When this occurs, gentlemen, you are going to be able to factor this into a plus b squared. What does that mean, Moro? Well, this literally means it's the square root of the first term plus the square root of the second term. Literally, that's what's happening, and then I'm squaring it all. The same exact format can happen, but you can have a negative. And it's going to be the same exact format when it's a perfect square trinomial. My first term will be a perfect square, but this time minus 2 times the square root of the first term times the square root of the second term, plus my last term is also going to be squared. When you have it in this format, you're going to have a factored binomial as a minus b squared, where this literally translated is the square root of the first term minus the square root of the second term. Now, the good news here is this is the one that I highly recommend and suggest strongly that you learn this, because it's going to be a 2-second question for you if you know it. But this is the one of all that we're going to learn today that you can do the old method. And let me explain what I mean by that. Let's say that I have, gentlemen, x squared, let's go, plus 8x plus 16. All right. You could go old school, old method. What times what is 16, but when added together is negative 8, guys? Negative 4, negative 4. Well, what's x minus 4 times x minus 4 using exponential notation? X minus 4 squared, correct? Okay, you could do that. And that works fine. However, not efficient at all. Not a good method. You can do it in a pinch, okay? You get stuck, you forget. Okay, no worries. You could do it. But let's really learn it today. So this is how I always test to see if it's a real perfect square trinomial, okay? This is how I test it. I ask myself, what's the square root of x squared? Okay. And that's a perfect square. Next, I ask myself, is this a perfect square? If so, what is the square root of it? Okay, 4. Now, if this is a perfect square, doesn't the middle term have to be 2 times the square root of the first times the square root of the second? Well, what's 2 times x times 4, guys? Does it work? There's a negative. So boom, bam, bing, done. That's how you do it properly. That's how you want to do it on an SAT, on an ACT, on a test, on a quiz. You want to be able to recognize. Now, if you don't know your perfect squares, you're going to be out of luck because you're not going to be able to recognize perfect squares. But I'm hoping that at this stage of the game, you do recognize it. Let's do one that's a little bit more difficult. Just a little bit more challenging. Okay, let's do this one. All right, guys. So I have 9x squared plus 30x plus 25. Is 9x squared a perfect square? What is the square root of 9x squared? 3x. Thank you, gentlemen. Is 25 a perfect square? What is the square root of 25? Thank you, gentlemen. What is 2 times 3x times 5? 30. So is this 2 times a times b? So it works. Plus, squared, done. Yeah, I heard a lot of ooh, yeah, it's easy. That's how you do it. Yes, sir. You promise? You good? You promise? Any questions on perfect square? We're going to do a bunch of examples, but I want to really make sure I got this really, really well with you guys. Okay? So like I said, worst case scenario, you could have done this Cuban method, right? Could have gone 9x, 9x, then you could have gone 9 times 25, which is 225. And you got to say, what times what is 225? But when I have to get is 30, it's 15. Because 15 times 15 is 225. 15 plus 15 is 30. Then you got an imaginary factor. A lot more work than really needs to be done. But this only is valid when you have the first and the second term that are perfect squares. And just because you have the first and the second term that are perfect squares does not mean that it's a perfect square trinomial. Because I could do this to you. And I probably will do this to you. And so will an SAT. They love doing this one. Something like, let's just say we got 4x squared. Let's put over here, I don't know, let's put 36 here. And then let's go, okay. Is 4x squared a perfect square? What is the square root of 4x squared? 2x. Thank you, gentlemen. Is 36 a perfect square? Okay, what's the square root of 36? Okay, awesome. What is 2 times a times b? 24. 2 times 2x times 6 is 24. Is that 24? Is that a perfect square? No. However, is this prime? No, because I can take out a 4. And then I've got x squared plus 5x plus 9. But then I cannot go any further than that. Did you see what I just did there, guys? GCF is not leaving anywhere anytime soon. These factoring skills are going to either help you for chapter 7 or hurt you for chapter 7. So please, does anyone have any questions on perfect squares before I move on, my brothers? Sir, my brother, thank you. I'm testing. Okay, I tested to see 4x squared. The square root was 2x. Square root of 36 was 6. Does this equal 2 times a times b? That's the question. 2 times 2x times 6 is 24. 24 is not 20, so it's not a perfect square, but I could take out a GCF of 4. Are you sure, my man? Thank you for your honesty. It takes guts. Anyone else before I move on, gentlemen? Please and thank you. Okay? Now, from here on out, guys, I hate to say it, but you're out of luck, Chuck. Now, there's no, oh, I could use the old method. This here is straight up memorizing. You have to learn the formats here. But they're easy. Difference of squares. When I have an a squared minus b squared, so that means I have a perfect square minus another perfect square. it's going to factor out into a plus b times a minus b. What did they just do here? Well, it's literally the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Literally, that's it. That's it. Literally. So for example, I have 9x squared minus 16. Is 9x squared a perfect square? Is 16 a perfect square? Are they being subtracted? So this is going to be factored out to be the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Do you see that, my brothers? It's literally that simple. Now again, guys, I'm not trying to be mean, but I am trying to help you understand where you're going to have pitfalls. If you don't know your perfect squares, you're not going to have a lot of fun with this section. Learn your perfect squares, please. Now, sum of squares, it's prime. It's not factorable. I put that in there because a lot of people confuse the difference of squares with the sum of squares. You cannot factor the sum of squares. You just can't. It's not factorable. So if you see 9x squared plus 16, you best put prime next to it because it is not factorable. Now, you always do check to see if there's a GCF, of course, because you can take a GCF out of everything, whether it's a perfect square or a non-perfect square or a difference of squares. You could always take out a GCF. Yes, sir. Correct. If you take out a GCF, then it's not prime any longer. Thank you, my brother. Very well done. Now, okay, here we go. Difference of cubes and sum of cubes. The good news, they're both almost identical formulas. The bad news, you got to know how to recognize cube roots, and you got to be able to figure out cube roots. So for a difference of cubes, I have a perfect cube, a cube, minus a perfect cube, b cube, and my formula is going to be a minus b times a squared plus ab plus b squared. What? Let me explain it. This really means the cube root of the first term minus the cube root of the second term. Then this first cube root is a, the second cube root is b. So then a, that first term squared, plus the first times the second, plus the second term squared. And it is exactly the same for a sum of cubes, except it's a plus b times a squared minus ab plus b squared. So if you notice, with the difference of cubes, when it's a negative, I start with a negative and I change to a positive. If you notice, with the sum of cubes, I start with a positive and I change to a negative. Now, this tends to really mess people up. So there's a little acronym that we can use, and I call it schisms. I know, I'm weird. I come up with these crazy names, I know. It's called schisms. Let me show you how cool schisms is. So yeah. Okay. Let's give you an example and show you how schisms works. Let's say that I have x cubed minus 8. First thing I want to do, guys, is find my first a and b term. So a, my first term, is going to be the cube root of x cubed. So what is the cube root of x cubed? Good. B, my second term, is going to be the cube root of 8. Don't worry about the sign when you're finding your A and your B. That sign does not change. That sign stays the same. It's negative. That's not the A or that's not the B. That's just a subtraction. You have A cubed minus B cubed. What's the cube root of 8? Okay, 2. Now, when you start here, guys, okay, you have X minus 2. That's my A minus B. Does everyone see that part really clearly, perfectly? They understand it, because without that part, you can't do anything. So, my brother, thank you. I'm gonna show you schisms right now. But before I can show you schisms, does everyone understand how I got this A minus B part right here? How I did this? Does everyone understand that? Talk to me, brothers. Okay? So then, if that's true, check it out. Schisms. Didn't I say we square the first term? So S for square. So first term squared. Didn't I then say you change the signs? C for change the sign. Didn't I say you multiply the first two square rooted, first cube rooted terms? So M for multiply, 2x. And then don't I square the second term? So plus 4. Schisms. Square, change sign, multiply A times B, square the second term. Schisms. Does that make sense? Okay. Now, any questions? Because now we're just going to practice. Okie dokie. Let's do this then. Thank you. All right, so let's factor each polynomial, brothers. So I got x squared plus 8x plus 16. Okay, before I start asking the question, do you recognize that these two are perfect squares? So what's the square root of x squared? What's the square root of 16? What's 2 times x times 4? 8x. Does this work? So it's a perfect square. So plus squared. Done. Done. Done, done, done. Number 2. Is the first term a perfect square? Is the second term a perfect square? What's the square root of the first term? What's the square root of the second term? What's 2 times x times 10? Yeah, that is number 5. I'm sorry. My bad. But what's 2 times x times 10? 20x. Does this work? But it's a negative 20, so what do I got to do? Put a negative and then I square it. Sorry about that. That was number 5. Let me properly go down the number line. 9y squared minus 64. Is this a perfect square? Is this a perfect square? Are they being subtracted? So it's a difference of squares, which is going to be the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Does everyone see that, my brothers? Okay, number 3. Is this a perfect square? Hold on. Got a little screen problem here. Is that a perfect square? What's the square root? No, it's not 6. 6x. Is that a perfect square? Yes, it's 5. What is 6 times 5 times 2? 60. Does this work? It's negative, so what do I do? It's a minus squared. Guys, are you seeing the power of this, of knowing the formula? You will answer questions in seconds, literally seconds, if you know what you're doing. How about number 7? Is the first term a perfect square? Second term a perfect square? Are they being subtracted? So it's a sum of squares. So how do we factor a sum of squares? You can't. Thank you. It's prime. Give me 1 second, please. Okay, thank you for that. Next, number 4. Okay, 8y cubed. What is that? Is that a perfect square? Is that a perfect cube? What is that? That's a perfect cube. Okay, and it's 27. What's that? That's a perfect cube. So I want to first find my a term and my b term. My a term is the cube root of the first term. My b term is the cube root of the second term. So what's my a term here, brothers? 2y, excellent. And what's my b term here, brothers? 3. So this started with a minus, so it's a minus b. Now schisms. Square the first term. Change sign. Multiply the first two terms, a and b. Square the last term. Schisms. Does that make sense, gentlemen? Questions on that, gentlemen? Yes, sir. Cube squared. What do you mean? Cube root. Okay. Cube root. A cube root, my brother, thank you for your honesty, takes guts. Thank you. A cube root, guys, asks the question, what number times itself 3 times gives me this value? So if I break down 8, this is going to be 2 times 4. 4 is 2 times 2. I'm not being sarcastic, guys, but this index tells you how many of one value I need to take out that value. So I have a 2 and a 2 and a 2, so that comes out as a 2. How many times does 3 go into 3? So I take out 1y, and that's how I got 2y as my a term. Does that make sense, my brother? Did you hear how everyone went, oh, thank you for asking that question. You just helped out a lot of people. Questions, guys? Okay, let us continue. We did number 5 already. How about number 6? Wait a second. Those aren't perfect squares, right? Oh, it's not factorable, right? Thank you. You pull out a GCF first. Then I have x squared minus 1. Oh, wait a second. Is x squared a perfect square? Is 1 a perfect square? Are they being subtracted? So it's a difference of squares. So this is 2 times square root of the first plus square root of the second times square root of the first minus square root of the second. We already did 7. That's prime. Now I'm going to go ahead and do 8. But let me first shrink this up a little bit. Okay. So for 8, is x cubed, is that a perfect cube? Yeah. Is 64 a perfect cube? Yes. For those of you that don't know, my brothers, again, I suggest, no sarcasm, learn your perfect squares, learn your perfect cubes. I've been telling you to do this for 6 months now. So please follow suit. So I got to find my a term, which is the cube root of the first term. And then I got to find my b term, which is the cube root of the second term. So what's the cube root of x cubed? X. Guys, just so you know, this cube root and that power of 3 cancel. You're left with 1x. Because there's 3 x's in here. I need 3 of one value to pull 1 out. So the cube root of x cubed is just x. And then here was the cube root of 64. What times what itself 3 times is 64, and it's 4. So now I got x plus 4 times schisms. Square the first term, change the sign, multiply the first and the second term, plus square the second term. Does that make sense, gentlemen? Promise. Okay. All right. We're moving on. Y squared minus 121. Okay, is this a perfect square? Is this a perfect square? Are they being subtracted? So it's a difference of squares. First term squared, square root of the first term plus square root of the second term times square root of the first term minus square root of the second term. Bing, bang, boom, done. Okay, 4y squared, is that a perfect square? 81, is that a perfect square? Let's see if it works and becomes a perfect square trinomial. So this is square root of 4y squared is 2y. Square root of 81 is, what's 2y times 9 times 2? Does it work? Plus squared. Is 27 x squared a perfect square? Is 12 a perfect square? No. But can I, thank you, my brother. I can take out a GCF. What's the GCF here? So if I take out a 3, I'm left with 9x squared minus 4. Now, is this a difference of squares? Yes. So this is 3 times the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the square root of the second term. Pay attention, Moro. And bada bing, bada boom, I'm done. Now, is negative 125 x cubed a perfect cube? Yeah, it is. Is 729 a perfect cube? Absolutely it is. So my A term is the cube root of negative 125 x cubed. What would that be, gentlemen? Negative 5x. Guys, remember, if you can't figure this out, break it down. 5 times 25 is 125. 25 breaks down into 5 times 5. There's 3 5s, you pull out a 5. What's the cube root of negative 1? A negative. Yes, sir.
Wouldn't it have been just easier to factor out the negative 1 first?
You can. Yeah, absolutely, actually. Yes, it would have. So why don't we do it properly? Yes. Thank you, sir. One of my brilliant students asked, wouldn't it be easier and better, more efficient, to go ahead and factor out a negative 1? And he's absolutely 100% correct. That is absolutely what I would do, and I apologize for not doing that. Now, I have that negative 1 that has to stay there, guys. That negative 1 has to stay there, okay? What's the cube root of 125x cubed? 5x. What's the cube root of 729? It's 9. Very good. Because 9 times 9 is 81 times 9 is 729. So now I have my negative 1 GCF. I got to follow the GCF always. A plus B. Now schisms. First term squared. Change sign. Multiply the first 2 terms. And then square the last or second term. Questions, comments, problems, issues? Talk to me, brothers. Please. Okie dokie. Now, last but not least, guys, just a general strategy. When you're factoring, no matter what you're factoring, whenever you look at something that you have to factor, always see if there's a GCF and factor it out if possible. Period. Always, 100% GCF. That's why it's number 1. GCF. Take out the GCF. Take out a GCF, guys. I know. Why is he a broken record? Because it's kind of important, and it's something that a lot of my students forget to do. Whenever you have to factor out the GCF first. If you have 2 terms, it's either going to be a difference or sum of squares or a difference or sum of cubes. If it's a difference of squares, it's x plus y, x minus y. If it's a sum of squares, it's not factorable. And then if it's a difference of cubes or a sum of cubes, then you have the schisms. If you have 3 terms, You're going to factor the trinomial into two binomials. You're either going to use the regular method of if there's a 1 in front of the x squared, what times what is c, but when added together is b. If there's another number other than 1 in front of the x squared, you're going to use the cubic method. Your setup is ax, multiply a times c, find the new c. What times what is the new c, but when added together is the b, and then imaginary factor. If you have 4 terms, you're going to factor by grouping. That's it. That's all of it, in a nutshell. So, for number 1, 2x squared minus 4x minus 48. What's the first thing I always have to do? Thank you, gentlemen. GCF. So let's take out a GCF. What's my GCF here? 2. Thank you, gentlemen. So I'm left with x squared minus 2x minus 24. Now let's see if we can factor this bad boy. I'm left with a trinomial. What times what is negative 24, but when added together is negative 2? Negative 6 and positive 4. Great job, guys. Great job. Awesome job. Next. I have a perfect square and I have a perfect square. I have 2 terms and they're being subtracted. So this is a difference of squares. Thank you. Good job. So this is square root of the first term plus square root of the second term times square root of the first term minus square root of the second term. Notice, guys, that y was to the 4th. The square root of y to the 4th is y squared. That's why I put that there. It's not a mistake. Number 3. What do you think I would do first here? Pull the GCF out. Heck yeah. What's my GCF here, brothers? 2. So then I have 2x cubed minus 3x squared minus 18x plus 27. Now I got 4 terms, so what do I got to do? Group. Keep that GCF, y'all. Keep that GCF, y'all. What can I take out of here? An x squared. Very good. And I'm left with 2x minus 3. What do I got to take out of here to make it look like 2x minus 3? A negative 9. Yes. And that's going to be 2x minus 3. But then, check it out. This is a 2 times. I factor out a 2x minus 3, correct? And I have a leftover of x squared minus 9, correct? Well, guess what? I'm not done. Because I have a difference of squares here. So this is 2 times 2x minus 3 times x plus 3, x minus 3. That's where the magic happens. When I have multiple factoring techniques in one question. Over here in number 4, last but not least, I can take out a GCF of negative 4x, leaving me with y squared minus y minus 3. What times what is negative 3, but when added together is negative 1? Negative 3 and negative 1 does not give you positive. Negative 3, it's nothing. So all I needed to do there was take out the GCF. Perfect timing. Thank you very much. Hope you learned a lot. Homework is valid. God bless you. And have a great day. Thank you. Bye-bye.